Okay, so factor out of GCF, greatest common factor, and factor within the parentheses, a trinomial. There's your perfect square. There's your square here. You only need to write this once, solve your roots, and there's nothing to check. Your domain was all real numbers, so you're good to go. Grouping, everybody group? It's like the 8 times C method, kind of. So group, factor, these two factors should be the same. And if it helps you, put a 1 here. There's your other factor, x squared minus 1. You could factor that again, or you could just set that equal to 0, since 1 is a perfect square. That part is up to you. I'll do both. You'll see me do both. Usually when I work stuff out on the board, I probably do more steps than you even do, just because I like to show everybody whatever it is that's going on. So sometimes kids will say, do I have to show this? No, I just show them all so that everybody sees what's happening. Get your solution set, and you should probably write your solution set. I took this out of the book, as you can see, like this. Stop me if you have any questions. Factoring is always one of those things that, those bad F words. Kids don't always like factoring. Okay, there's nothing to factor out of this one, no greatest common factor. So use your A times C method if you can get this. Use your A times C. Did you come up with those factors or no? 64? So you use negative 64 and negative 1. And yeah, and then you're going to have to just group them, and you should have gotten these, right? Or no?
I did not find it.
Okay, so if you do this, this is 64. So Therese said negative 64, negative 1 multiplies to positive 64, but gives me negative 65. Just plop your x's next to it. Rewrite this. Doesn't matter what order you write it in. God bless. Out of this guy, we can factor out a 4x, so you're left with x minus 16. Out of this guy, you almost have this, but they're opposite signs, so you got to factor out a negative 1. This will force that to change. So you got 4x minus 1 and x minus 16. Oh, this was to the, sorry, my mistake here. I didn't see the 4th power, so you're going to have to take out a square. I'm going to change it around a little bit. Then this is going to become a square, square, a square, a square. And you're going to have to factor again. You have 2 perfect squares. If you instead set this equal to 0, that's fine. Square root of both sides is going to work. Just remember, when you set it equal to 0 and you undo the square, you have a plus and minus. So that gives you these and these. Okay, boys, you have homework?
Yeah. The vending machines weren't working, so we have to go to the cab.
Okay, which you should have done before you even came upstairs, right? Do I hear yes, Mrs. Moore?
Yes, Mrs.
Yes, Mrs. Moore. There you go, Mark. Yeah, honey.
Wait for them.
What?
I got it as I was asking.
When I first did this, I forgot that was an x to the 4th, so then I just stuck the squares back in here.
Yeah, so it would be the parentheses 4x squared minus 1, and then the parentheses x squared minus 16, and then it would be that
Yes.
step.
Okay. And then this step over here. I just didn't rewrite that part, because then it's the same.
Okay. Thank you.
Make sure you can do the A times C method. Okay. You do this one? Okay. This one has a common denominator. What's the common denominator?
T squared.
T squared. So on the top, it's kind of like a 4 and a 2. Okay, you have to take the higher one because you can't fit the higher one into the smaller one. So you're just going to take the higher one. Just put it on the top, like this. Cancel out your T squared. This one goes into here 1 time. This one needs the T squared. If it helps you, if you'd rather do it this way, rewrite it and factor. And when you factor it this way, remember, there's your 1. It makes it a little bit easier to do it that way because you like the t squared first. So now they're both positives. It kind of worked out nice. So you want factors of 15 that add up to 8, and you get your 5 and your 3. Can you do this one either way? Absolutely. And then set them equal to 0. And try to make your set notation. The book did it, which I don't use the book for too long, you're going to see. It's just that my writing is horrendous, so I try to like use something else. Okay? It works the same way as any other fraction does. Yes? You multiplied by t. What would you do with the 15?
Later on I subtract.
Okay, so did you group these together? Did you put a t on top, t on the t?
Yeah.
T on top, t on the bottom. So then you got an 8, you got this. And then what?
And then I think I put them together, added them both together.
1 plus 8t over t squared?
Yeah.
And then you move this to the other side, cross multiply?
Yeah, move over the 15 and no, actually I multiply it by t
Squared. Fine?
Because
Absolutely fine. Absolutely fine. What Brian did was he just took 2 pieces and he found the common denominator and added them together and then made it one term, and cross multiplied. Absolutely fine. I'm not concerned about if you take a different routine than me, as long as it's sound, and it's fine. It's fine. I tend to do one denominator all the way through. Other teachers like to separate them. I tend to just push one all the way through. Whichever one works for you guys. Okay, radical, first step. Excuse me, first step, find your domain. So take this out, set it greater than or equal to 0. We can have a 0. And your domain should be from 10 to infinity. Okay, so now if I find my answer and it's not within that domain, I know it's not going to work. I'm still going to check it. So move this to the other side, square both sides. This pops out. Everybody good with this? And check. I don't need a formal check. You don't have to say check and rewrite the problem, but you do have to do a mental check. And all I need to see is if it doesn't work, reject. Cross it out and make sure you say reject. If it's the only possible value of x and you rejected it, then you have to say still no solution. Okay, this guy, domain restriction first, so you know what your domain is. Move everything to one side, square both sides. We looked at this yesterday, and we said there's no easy way around this. You have to multiply this out. So you multiply this out, this guy pops out, subtract the x, subtract the 1, and now you're left with this. 2 terms. I'm not a trinomial, I just have 2 terms. Greatest common factor. Factor out an x, set them both, God bless you, set them both equal to 0. Now, when we test this guy, excuse me, when we test this guy, even though it's within my allowable domain, it doesn't work. So make sure you go and you test them. And the 0 works fine. And just because it's a negative, don't reject it. Put it back into the problem and see if it works. Okay? Stop me if you have any questions. Okay, cube root works the same as a square root. Instead of squaring, you're going to cube it. The cube roots, how come we have no domain restriction for a cube root? How come we didn't do that? Anthony?
Cube root can be positive or negative.
Can be a positive or a negative. Good. So we have no domain restriction on our cube root. So we don't have to worry about that. So still follow the path, get it to one side, and instead of squaring it, cube it. If it was a fourth root, I would put it to the fourth power. Cube, cube. Be careful, make sure you cube the negative with it. Take it out and check it, make sure it works. And again, we can have a negative or a positive under that radical sign. 134, we could almost see by looking at it, it can't possibly work, right? How could you take the same number and subtract 5 and add 5 and get the same answer, right? But we could square it. Now, as soon as you subtract x from both sides, you get 5 is equal to negative 5, which we know is not true. Therefore, no solution. If it had 5 is equal to 5, then it would be infinite solutions. Okay. And if you saw it up before you even did it, that's fine too. I gave you this one, right? This one you had? Okay. How do we do with this? We have two domain restrictions. X is greater than 0 and x is greater than 5. So here when we put this on, here's your 0, here's your 5. If I took the 0, then one of these guys is not going to work. If I put a 0 in here, it's going to give me a negative. So I have to take where they overlap, what they have in common. So my domain from 5 to infinity. You could move either one to the side, and if you have two negatives, just divide by a negative, make it positive to make life easy. Whichever you decided to do. When you square this guy, remember there's no easy way out of that. That's this. You have to write it twice. Same thing. Write it twice and FOIL it out. Distribute it out. Collect your like terms. Now, over here, at this step, if we can divide by 2, just work with smaller numbers. Do you have to divide by 2? No, you can still square both sides. In this case, we just divided by 2, made it a little bit smaller. But if you worked it out without it, just remember when you square both sides, you're squaring that 2 as well. If this was 16 and this was 4, 4 goes into 16 4 times, you're still the same. This pops out. And check your 9. Your 9 is in your allowable domain. Just check it and make sure it works. Is that the last one? I took out the other one. Okay. Questions at all on these? Now, before I hit this one, let's just look at a very small one. When you have an absolute value, very, very simple. When you struggle with rules, keep it simple. Matthew, you didn't get one? Sorry about that. Sorry. Okay, so now, what can the value of x be in this equation? 3 or negative 3. So it has two roots. It has a negative and it has a positive. So that's what we have to remember with absolute values. It has two paths to follow. So I can take whatever this is, keep it positive. I can take whatever this is and make it negative. Okay, so I have to remember that. I have two paths. Take the positive, take the negative. So the first thing I'm going to worry about is a domain restriction. Do I have any restrictions with these x's? No. So I should have a domain of all real numbers. My range, however, will be a little different, right? Because I'm absolute value. But all we care about is our inputs right now. What can we use? So we're going to follow this set of instructions. We're going to isolate your absolute value. Just like you isolated your radicals, you have to isolate your absolute value. By isolating it, keep it by itself. Get everything else to the other side. I tend to keep mine on the left side. If you do it on the right side, just remember to switch this process a little bit. But I tend to keep mine on the left side. I isolate the radical. Now I solve for negatives and positives. So if this is by itself, same thing like over there, you're going to do this. You're going to take whatever this is, take it out of the radical, Don't change the radical. For the positive root, did we change anything here? Did we change anything on that other side? We kept it the same. It's okay that that says -4. That's part of its argument there. Now we're going to take this out again. And we're going to say set this to the negative of whatever this thing happens to be. So because it's more than one term, over here we just had one term, we just set it equal to the negative. But because it's more than one term, we have to put parentheses. Agree? Our rule is positive, negative. Isolate the radical, set it to the positive, set it to the negative. Whatever this is here, we consider this the positive side. Don't change your positive side. On your negative side, you just negate what's on the right-hand side. So now we solve. Unfortunately, it's a little bit long, so we have to add 4x, subtract 6. And on this side, we're going to have to distribute this. Then we're going to have to subtract 4x, add 6. Okay? Your next step would be factoring and checking. Don't forget, because we manipulate this, because we make this be the opposite of everything, doesn't mean it's not going to work. It means we have to check everything. Generally, what happens is when you have another x somewhere else on the other side, that's what could throw you off. So we're going to solve and check all our roots. So we're going to factor this guy, x minus 6, x minus 1. So x is equal to 1 and 6. Okay. Can you guys see that? I could probably move this down if I didn't change the color. We're going to do this guy. What is this factor to? So x plus 3, x minus 2. So this becomes -6. This becomes positive 1. And I'm good to go. So this is my x is equal to -3, x is equal to 2. So right now we have these possibilities. Let's just list them around here. -3, 0, 1, and 2. Now we have to check them. Okay? This half of the room, from Eric on, check the first two. Yes? The 0 of, hang on, thank you. And it's not 2, it's 6, right? Thanks. -3, 1, 2, 6. My writing got a little rolled over there. Thanks, Grace. Stop me whenever I do something wrong before I keep on going. Okay, I will never make a conceptual mistake, but writing down while I'm talking is difficult. Yes, Brian?
On the second side, why didn't you distribute negative the 4x or 6?
Why didn't I?
On the other side.
There's no negative to distribute. That's the only term. That term has a negative. It just so happens that was there on the original piece. And the original piece was there, so I don't have to worry about it.
You had to distribute it on the other side because that's negative.
Because we took a negative. It's kind of like this. If I just leave these in parentheses, this is a 3. I pull it out. I pull it out here. If this said 3 plus x, I would have to do this and distribute the negative. I have two roots, a positive and a negative. The positive, the first side, the right side, I don't change anything. I just keep it as is. The left side, I take the opposite of everything there. It just so happened that this negative belongs to that term. I leave it. Even if it said this, if it originally said that, I would leave that there, and on this side, I would negate it. I just follow one rule, no matter what this thing looks like. So now, this side, check -3 and 1, and these rows, check 2 and 6. Tell me which ones work. Negative 3 doesn't work?
No, it works.
It works. Negative 3 works?
Yes.
Does 1 work?
No.
No. Okay, so I've got 1 here. 2 and 6? 2 works? Doesn't work? Works. 6 not. An easy way to do when you check is just check this side first. So if this ever is equal to a negative, can it be? So if I take 6 and I eyeball this and I say 6 times a negative 4, wow, that's a big number. This is going to be negative, isn't it? My absolute value is always positive, can never be negative. Do a mental check as far as you need to go. Sometimes it goes that side first. Obviously, you have to check the inside of it, but you can probably get rid of the other ones.
I got that 1 works.
Which one?
1.
1? Okay, so let's try 1. So this gives me negative 4. This gives me a 2. So 1 minus a 3 gives me a negative 2. So 2 works. So 1 works. So negative 3 doesn't work? So this will give me a 12. This will give me an 18.
Yes.
Two doesn't work.
2 doesn't work.
So I'm trusting you guys.
Negative 3 and 1 work.
Negative 3 and 1 work.
Okay, so now we're back to this, negative 3 and 1. That's why I have you all doing them in a group here. All right, I need popular consensus here. I'm not doing all the work.
Wait, 1 works?
X doesn't work.
1 works. 1 works. And negative 3, this will become positive here. And 36 minus 18, this will be 18, and 18 works. Good job, guys. Okay. So you guys all have to agree in your groups which is working, which isn't working. Good. Okay. So basic path should isolate these guys. If this was on the other side, and by isolate, I mean this. If it originally looked like this, if this was how it originally looked, this has to get moved to the other side, just like that. The radicals have to be by themselves, the absolute values have to be by themselves. One of the biggest mistakes I see. Okay, inequalities. Don't worry about all that stuff up top. It's kind of a little bit weird. We'll go through the inequalities when we hit them. So you're still going to isolate your absolute value. That's a must. A greater than, a greater, so kind of like what I usually tell kids, kind of misspell this. Spell it like this, greater. This gives you an or statement. And ors on both go out like this. Generally, your or statement will go out like this, 95% of the time. A less than is an and statement. Okay? And we're going to write again our solutions in interval notation. Sometimes it's easy to graph them, and sometimes I'll ask you for a graph on a number line. When you do your number lines, all I want is this. If my critical values are negative 5 and 5, that's all I want you to put here. I don't want you to write out the 0, the 1, the 2, the 3. Just go to the critical values and then where your arrows go. So we kind of keep it a little bit simple. Now, there's a couple of ways to work this. Did you do these last year? Oh. Baker's Kit? Kind of. Baker's Kit? Baker's Kit. I know Baker would do this. Mr. Baker follows the curriculum to a T. So I pretty much, and so does Imperialis, but Imperiali wasn't here last year. Okay, now, here is my less than. I'll do it both ways, but this is how I do a less than. So, for an inequality. So I say, okay, my absolute value is isolated. This is a less than. This is going to give me an and statement, like in here. My path is in here. So I'm going to build my and statement. I'm going to drop this out and go like this and build my and statement. Whatever is over here, if it's 2 plus x squared plus x, I have to put the whole thing into a negative. Whatever is on this side, I'm negating. Build your and statement. And now I solve. Simultaneously, I need x by itself. You can only do this if I'm able to get x by itself. If there's anything else in here and I've got x's on the other side, you can't do it this way. And then I'll show you how to do it. This is the simple, quick way. Did you do your inequalities like this with the and statement? Usually, most of you at least have seen this. Okay, so now we take this and all we have is two critical values. Put the 3, put the 7. Are they opened or closed? Open. And we've already built our and statement. Your interval works nicely. If there's an x or something else out here where you can't resolve your x's, you can always do the same way we do your radical. It almost has the same pattern. Isolate your absolute value, make a positive root, make a negative root. There's one little hitch to the negative side. When I do this, I pull this out. That's this piece right here, isn't it? That's this piece right here. When I come here, this is an or statement. When I come here, oh sorry, this is an and statement. When I come here, I pull this out. I take the negative of whatever's there. But do you remember what you do in the last step when you change a negative, when you divide by a negative or multiply by a negative? What do you do to the sign? You switch the sign. So this sign now has to go this way, which is technically what this is backwards. And then you solve for both. Now when you come out to this one, you're going to get x is greater than 3. You're going to get x is less than 7. This has to say and. Because you don't want them to keep just going opposite. You only want the ones in the middle. But because you're going to write it in interval notation, it'll work itself out. Because if I left this, this says this keeps on going here. This says this keeps on going here. But I only want the ones where they cross. But because you do interval notation, it'll work. That problem won't be so bad. So you can do that one either way. And if there's x's or anything on the right-hand side, you're going to have to do it this way. Okay, let's take a look at an or statement. My absolute value is isolated. Do I have any domain restrictions?
No.
My denominator doesn't have a variable. So now, this goes over here. You can't manipulate this until you switch it around. There's my positive. Now I want my negative. This comes out, switch this, and now what do? I take this, whatever this is, and I negate it. Same rule as a radical, same rules as my absolute value, my regular, my equality. But I have to just switch my sign because it's an inequality. Now you're going to solve for both sides. And I have a fraction. So let's just get rid of this guy first. I'm going to subtract 1. I'm just going to multiply this guy by what? To get a t by itself. 2, but I want a positive t. Negative 2. And what's going to happen when I multiply by a negative? This will give me a positive. What do I do to the sign? Switch it. Okay. I'm going to subtract 1 from here, just to get that by itself. It looks a little bit easier. I'm going to do the same thing, multiply by a negative 2. This becomes a positive, but when I multiply or divide by a negative, you're going to switch your sign. So now I've got 2 things. I've got the negative 8 going this way, and I've got the 12 going this way. So interval notation, negative infinity to negative 8, or 12, whoops, bracket, it's an equal sign, or 12 to infinity. Could you multiply everything by 2 first and get rid of the 2? Absolutely, I don't care which way you do it. Okay, so for homework, do that work. I get you doing the equations part with you. We'll do that tomorrow. So the back part, Don't do the back. Don't do the very last page. The very least. Don't do the last page. We get to do that part yet.
Okay.